So energy of a body in motion, so we've got some mass and it's moving, and we would say that the energy is proportional to the mass, we suspect, like we did the last one, it's a suspicion. And the energy is proportional to the speed, velocity, to be more precise. So therefore, E is proportional to mv. And these have got a power, again, I'll exaggerate, draw them a bit bigger than it's normal. And some, let's do our equals k, some constant, A, velocity b. You might see where this is going if you know your energy formulas. Okay, so if I do the same thing again as we did earlier, put our units in now, the dimensions in. So for energy it's m
L squared T
squared, right, T, is that minus 2, yeah?
minus 2, yeah.
Right. And on the other side, we've got, so this is a mass to an A, and we've got a velocity which is changing distance and time, in short, so B.
Where'd you get that from?
That's, put my units in, dimensions in, sorry. So that's mass,
Yeah.
and that's our velocity, length,
T.
meters per second. So length, changing length against time, per time. So if I bring my units in, I can draw properly. So I'm going to get thus. So this would be L to the B and T to the minus 1B, or just minus B if you prefer. Okay? Depends on its way out. Just go with it. So, same as before, so equate powers or indices or exponentials, whatever you want. Right, so for M we have, on the left hand side we've got 1, and on the other side we've got A. So that's a nice quick one. So A equals 1 in other words. That's nice and quick. For L, we have 2 equals just the B, is it? Yeah. That's nice. So just B equals 2. And then for T, we have minus 2 equals just the 1, so that's going to be minus 1B.
Where are you getting that from?
From here. So what I've done, I've looked at the power of each of these terms.
Mm.
So the left hand side, for example, is 1 for this, it's 1.
Right.
And on the right hand side it's A. So those powers equate to A equals 1. B's, L's a similar thing, L's a 2 on the left, B on the right, so you end up B being 2.
And that's why it's minus 1, yeah.
And then this is giving me that. Now, this one don't give me a solution, but I know what B is. So B equals, let's have a look, minus 2, let's put it there for, minus 2 equals minus 1 times 2. Have I got that right? Something feels wrong. Minus 2, 2. Something feels wrong.
Shouldn't that be minus 1b? So minus b, which b is 2 then?
Yes, yeah. Minus 1 times 2. B is 2, so times 2. Minus 2 on the left. I've done it right.
Yeah.
If I take that to the side,
We've got b already anyway.
yeah, it's going to cancel out is what it's saying. If I take 2 to the side, I'm going to have minus 2 plus 2 equals 0. So basically it's 0 is what it's saying. Okay with that? So in other words, this one is 0, the t's. It's power 0. So that means if we go back to our formula here, we've got, let's do it here, E equals K, and we've now got my powers. So M is M is an A, which is a 1. I'll put it in, we don't need to put it in, but I'll put it in. V is 2. Okay. So that actually, you might recognise that formula. Kinetic energy is mass times velocity squared. K constant we end up finding out from experiment is actually a half. So that's your standard formula for kinetic energy. Okay. So again, if we check our balance of the left and the right hand side, so this ended up being 1, didn't it? 1 and 1. There's 1. This was 2, and we got 2. And this ended up being same again, 2 and 2, minus 2, minus 2. But it's balanced as well. Hopefully, thankfully. Okay.
How do you get that half in the end?
Right. The half,
Yeah.
this one. Right, this is only, this doesn't come out of this exercise. We just know it's a constant.
Right.
So what we've got to do is set up a test in a laboratory, in a science lab, and just keep doing the exercise and see what value we end up finding for it. Find out what's missing really,
Yeah.
and it ends up being a half. Quite often with constants you can have an educated guess from either something you already know or some logic like the 2 pi one on the last one. The logic said it would be 2 pi.